These are the answers to the problems trying to get you to find the measure of these angles using the fact that corresponding angles, alternate exteriors, alternate interiors, are congruent when you have two parallel lines cut by a transversal. And so here in this situation we do have two parallel lines, M and N, and they're cut by transversal P, and they're also cut by transversal Q, right? So that set of angles adhere to these rules, and then these sets of angles also adhere to these rules. And then we have the line number 7 to 12, and you can see that P and Q are not parallel, but W and V are parallel. Right? We have the two arrows, and they are cut by transversal P, and they're also cut by transversal Q. So these are the answers there. Notice here on number 12 that we need to use two theorems. We need to use that corresponding angles are congruent, and we also need to use that they're a linear pair, which means that they're supplementary. So we use the supplementary comp theorem as well. Right? So then our next section here is that algebra can be used to find unknown values in angles formed by transversals and parallel lines. So for example, let's say measure angle 1, this one here, is equal to this expression, 3x plus 15. And then measure angle 2, this guy over here, is equal to this expression, 4x minus 5. And then measure angle 3 is equal to the expression 5y. And we're to find the value of x and y. Okay, so find x and y. So because P and Q are parallel, right, we can tell by these little arrows, then we know that angle 1 and angle 2 are congruent because they are corresponding angles. And so if we know that they're congruent, that means we can set them equal to each other. Measure of angle 1 is equal to measure angle 2. Then we can use substitution to substitute what measure angle 1 is equal to right here, which I'm going to do. Let's get 3x plus 15 is equal to, and then we're going to substitute what m2 is equal to in the place of m2 in this equation, so we'll get 4x minus 5. And then we work out the math, right? So I'm going to subtract 3x from both sides, and I am going to add 5 to both sides, and I'll get 20 is equal to x. So I found my x, it's 20, and now I need to find my y. And how can I find my y? Well, we have here that x is 20, so we could substitute into measure of m2, right? So let's go ahead and do that. Measure angle 2 is equal to 4 times 20 minus 5, so it's going to be equal to 85 minus 5, it's going to equal to 80 degrees. Alright, so now that we found measure angle 2, then to find measure angle 3, they're equal to each other, right? So I can go ahead and set 80 equal to 5y. Right? So what we have is measure angle 2 is equal to measure angle 3 because they are corresponding angles. And then I could substitute in 80 for m2, and I could substitute 5y for m3, and then I could solve for y by dividing by 5 on both sides. So I get y is equal to 16. So those are our two answers there and there. The next one is what's this? R and S are parallel, so M2 and M3 are equal because they are corresponding angles cut by transversal Q, and so they're corresponding angles. And then we need to find x and y. So how do we do that? Well, we can set them equal to each other, and then we'll substitute in their values. Oh, I think I did this problem kind of backward. So I'm substituting in 4x minus 5 for m2, and then I'm substituting in 5y for m3. And then I think the idea here was once you find x, then you can use this equation here to find y, right? Which is what I did here. So y is equal to 16. But yeah, anyhow, that's our example. And then we have some exercises which I'll show the answers to in the next video.